Hello, this is the first video in the Calculus 2 series on inverse trigonometric functions for OCR Pure Core Further Mathematics, and it looks at differentiating arcsine x. There are two main ways of writing the inverse sine function. Both arcsine x and sine to minus 1 of x are commonly used, and you will see sine to minus 1 on your calculator. It is important to remember that the sine to the minus 1x refers to the inverse sine function and not the reciprocal 1 over sine x, which is equal to cosec x. So we will use the arcsine x type of notation throughout these presentations. Here is a graph of arcsine x. As you can see, the range of arcsine x must be noted to be y lies greater than or equal to minus pi by 2, less than or equal to pi by 2. And you will no doubt relate this to your work on functions generally. The tangent drawn in blue on the graph shows the gradient of a curve is always positive, and it's worth noting that dy by dx is greater than or equal to 0, as we will be using this information later. To differentiate y equals arcsine x, we will need to use implicit differentiation. Y equals x. Differentiating this gives us cos y dy by dx equal to 1. Differentiating with respect to x, that is. So therefore we may write that dy by dx equals the reciprocal of cos y. If we use the identity that cos squared theta plus sine squared theta equals 1, or equivalent to 1, then we can rewrite 1 over cos y as being 1 over the square root of 1 minus sine squared y, noting that that could be the positive or the negative. If we then use that sine y equals x, we will note that that then is 1 minus x squared. However, because the gradient dy by dx is always greater than or equal to 0, as we noticed from the graph, we only need the positive square root and can write dy by dx equal to 1 over positive square root of 1 minus x squared. If we check back with the graph, now that we know dy by dx is 1 over the square root of 1 minus x squared, and that the gradient of x equals 0 is therefore 1, we can see that except at x equals 0, the gradient of the tangent for red curve y equals arcsine x is steeper than that blue line y equals x. So the algebra agrees with the shape of the graph. Moving on to a more general derivative, we will calculate the derivative of y equals arcsine x over a in the same way. Sine y, in this case, equal x over a, so cos y dy by dx equaling 1 over a. Dividing through then by cos y and using that same identity. Remembering in this case that we must write it as x over a, Then a little tidying up on the algebra gives us a squared minus x squared. As before, we only need the positive square root because dy by dx is greater than or equal to 0. So this is a summary slide which shows us the results for differentiating the inverse sine of x and then a more general result of x over a, which we will use when we look at integration in a later video. Note that differentiating the inverse cosine functions may be done using a similar method. In the next video we will cover differentiating arctan x.